In this video we're going to look at our negative index, so x to the negative n is the same as 1 over x to the n. Let's have a look at that in practice. So let's take a list of numbers here which I'll write out now, and what you can see is I've got 3 to the power of 4, 3 to the 3, 3 squared, 3 to the 1, 3 to the 0 and so on following down. Now 3 to the power of 4, 3 times 3 times 3 times 3, which is 81. 3 to the power of 3 is 27, 3 squared we know is 9, 3 to the 1 is just 3. Now what we've got here is we've got a pattern. Okay, so every single time, if I was to give you this just as a number pattern, 81, 27, 9, 3, then what's happening each time is we're dividing by 3. So that divided by 3 is 27, divided by 3 is 9, divided by 3 is 3. Okay, and that makes sense because each time we're going down a power, so there's 1 less 3 multiplying. So we're going to continue that pattern. So 9 divided by 3 is 3, 3 divided by 3 gives me 1, and then 1 divided by 3 is 1 over 3, or a third, and if I divide a third by 3 I get 1/9, and if I divide a ninth by 3 I get 1 over 27. Now what we've actually got here is to look at these ones that are fractions and see if we can compare them to what we have over here. So if we have a look at the first one, 1 over 3, then we could, if we wanted to, write it as 1 over 3 to the power of 1. Now we wouldn't normally do that, but just for the point of illustration here, we're going to put that in. This one, 1 over 9, could also be written as 1 over 3 squared, because 3 squared is 9. And this could also be written as 1 over 3 cubed. Now what we want to do is compare here these parts. So 3 to the negative 1 is 1 over 3 to the positive 1. 3 to the negative 2 is 1 over 3 to the positive 2, and 3 to the negative 3 is 1 over 3 to the positive 3. So this is basically the rule we have up here. If we have a negative power, if I move it to the bottom of the fraction, then it changes the sign of the power. So we're going to try the same with this. I'm going to fill in the first 4 here for you, and what we can see is we have 16, 8, 4 and 2. So each time here we are dividing by 2. So 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. We're going to again continue that pattern on. 2 divided by 2 is 1, 1 divided by 2 is a half, a half divided in 2 is a quarter, and a quarter divided in 2 is 1/8. And again, what we're going to look at is these fraction ones down here at the bottom. So each of them can be rewritten. So the half there can be written as 1 over 2 to the power of 1. We would never normally, as I said, write the power of 1 there, but just for illustration. 1 over 4 is 1 over 2 squared, and 1 to the 8 is 1 over 2 cubed. And again, what I'm looking for is the comparison between this part and this part in each case. So what we have here, if we look at this rule, x to a negative power is 1 over x to the positive power. So 2 to the negative 1 is just 1 over 2 to the positive 1, 2 to the negative 2 is just 1 over 2 to the positive 2, and 2 to the negative 3 is just 1 over 2 to the positive 3. We'll now go and look at a few examples putting this rule into action. So what you can see in this example here is it's asking you to simplify but also to leave your answer with a positive index. So these are just normal simplifications based on the rules we've covered so far, and we'll start here with part A. So x to the 5 divided by x to the 7. Now when we divide indices, remember we subtract the index number, so 5 take away 7, that's going to give me x to the power of negative 2. Now normally that's fine as an answer, but this particular question says leave your answer with a positive index. So if I have x to a negative power, like x to the negative n here, it becomes 1 over x to the positive n. So that means that this is going to become 1 over x to the positive 2, and then I have a positive index here. In other words, this 2 is now positive. So that's the first one complete. We'll look at part B here, and we'll go through the normal process. Now, we've got 2 divided by 5. Now 2 doesn't divide by 5, so I'm going to have to write that as a fraction. So 2 divided by 5. And what we've got here is x cubed divided by x to the 7. Now, if I've got x cubed and I'm dividing by x to the 7, I'm going to do 3 take away 7 from my power, and that's going to become x to the power of negative 4. But again, that has a negative index, and I'm specifically asking this question for a positive index. So what I need to do is take that down to the bottom, and when I bring it through this fraction line, it will change the sign of that power, and that's a good way to think about that. So that's going to become 2 over 5x to the positive 4. Now this is exactly the same as the rule we have here, so when I've got that x to the negative n, remember it's x to the negative n over 1. Okay, we don't normally write the over 1 part, but we could represent that easily like that. If I want to bring that down, I need to remember there is a hidden 1 here, and when I bring this part down, it is going to change the power of that x. So we're going to end up there with the 1 at the top still there, the 1 at the bottom still there, and x to the negative n is going to move from there down to there and become x to the positive n. So writing that out in simplest terms would be just 1 over x to the n. Okay, we'll look at part C here. We've got 5x to the negative 3. Now, again, we want to think about that as almost being 5x to the negative 3 over 1. Because what I want to do is I want to bring that down. But remember, the power here, this power of negative 3, is only actually on the x. So if I want to make this a positive power, it's only the x to the negative 3 I'm going to bring down and make that x to the positive 3. So the 5 will remain at the top of that fraction. So 5 will remain where it is, so 5 at the top, and the x to the negative 3 will move to the bottom of the fraction and become x to the positive 3. Lastly, we've got this example here. Now, what I've got here is 6x all to the power of negative 2. So I could treat this bracket here as if it were just a normal x. In other words, I want to take that and put it to the bottom and change the power. So that bracket to the negative 2 becomes 1 over the bracket to the positive 2. Now, we can just put the 6x back in there. At the moment, that's not quite fully simplified. We still need to remember we've got a product in here, and this power will act on both parts. So it'll be 6 squared and x squared. So let's finish that one off, and I'll go across the way, which I wouldn't usually do, but just for space. 1 over 6 squared x squared, which is 1 over 36 x squared. I'll give you a chance to try 3 of these yourself. So pause the video here, try the 3 questions, and then press play when you've finished each one to check them. Okay, in the first one here I've got x to the negative 5, so this is the law we're using. X to the negative power will be 1 over x to the positive power, so that is just simply going to become 1 over x to the power of positive 5. In example B here, the 3 and the 2 are not going to move. The only thing that's got the negative power acting on it is just the x. That negative 2 has got nothing to do with this 3. So what we can do is we can take this x to the negative 2 here, and we can shift it to the bottom of the fraction and make that x to the positive 2. So as I said, the 3 and the 2, they're not actually part of the change we're going to make here. So that x is going to go to the bottom and become the power of positive 2. Lastly, in the same idea here, this negative power of 4 here is only acting on the x. It's got absolutely nothing to do with this 5. So this 5 is going to stay up at the top of the fraction we're going to create, and the x to the negative 4 is going to move to the bottom and become x to the positive 4. So as I said, 5 is going to remain at the top there, and we're going to push that x to the negative 4 down to the bottom and make it x to the positive 4. Basically, a good way to think about that is anytime you take an x to a power and you push it through a fraction line, it will change the sign of it.